is computer science anyways? Is it the study of computers? Well, not exactly. The answer might surprise you. So, one of my favorite quotes about computer science is from Edgar Dijkstra, one of the founding fathers of computer science, who said that computer science is no more about computers than astronomy is about telescopes. Let's think about that for a minute. An astronomer uses a telescope as a tool to study the stars, but they're not actually studying telescopes, they're studying the stars. In the same way, a computer scientist uses a computer to study computer science. And in fact, computer science as a field was born before the first computers were created. Another one of my favorite quotes that I like to share is from someone named Steve Jobs. You might have heard of him. Everybody in this country should learn how to program a computer because it teaches you how to think. To be able to tell a computer what to do, you have to think very clearly and precisely. It's one of the biggest challenges that some new programmers face when they start undertaking computer science. And the reason why I think it's so important to learn computer science is because technology is increasingly transforming every aspect of our lives. Are we going to sit back and let others decide how this technology will be used? Or are we going to become a part of that conversation? By knowing how to program, by knowing the basics of computer science, you'll be able to engage in that conversation. And so that you can be one of the many that will be dictating how computers and technology and software will be used in the future, not just one of the users. Now, computer science sometimes can be challenging. And largely it's because giving and following directions can be hard. Have you ever tried to give someone directions or follow a recipe? So, for example, I don't know about you, but sometimes I'll follow a recipe that I find online. Look at these awesome rubber ducky cupcakes. Nailed it? Not quite. So sometimes, despite our best efforts, we have trouble following directions or communicating them to others. This is why computer science gets hard, because giving precise directions is challenging, whether it's leading someone through a maze, writing a recipe, or giving directions to an unfamiliar location. Unlike humans, computers cannot fix ambiguous directions. Imagine I had a cake recipe where it told the baker to put the cake in the oven before they added the flour. Now, I'm pretty sure any human baker looking at that recipe is going to figure out that they need to mix the flour in before they put the cake in the oven. Even the least experienced baker. Computers won't do that. They will relentlessly follow whatever instructions we give them, for better or worse. And how do we give computers precise directions? Well, we use something called algorithms as programmers. An algorithm is a precise series of steps that accomplishes some task, or in other words, solves a problem. So what does the problem-solving process look like for computer science? Well, imagine you've got a problem such as, how do I automatically find the minimum in a list of numbers? Programmers use a programming language, which is a pre-agreed set of instructions that the computer already knows what to do with. So the human is basically learning a language, a special restricted language that the computer also understands. They formulate their idea, their solution in terms of an algorithm, which is a series of steps for programming any programming language, whether it's Python or one of the many other programming languages out there, such as Java, C, C++, C#, Ruby, Perl, or PHP. And then they implement it as a program in a specific programming language. And in this class, we'll be doing that in Python. Once they've implemented their solution in a program, they can run it to actually solve the problem. In this class, we're going to be covering the 7 basics of computer programming. Variables, math and logic, input and output, conditions, loops, functions, and lists. The reason why these 7 basic concepts are so important is that they can be combined in infinitely many ways. And once they've been mastered, you can implement any program that's ever been written in any programming language. Now, you might be wondering, if all I need are those 7 concepts, why are there more courses in computer science besides just this one? Well, in theory, these 7 concepts are all you need to implement any program. But in practice, it would be very difficult to implement just any program using only these 7 things. And so that's why there are more steps and more classes in learning computer science than just this course. And what you may notice is that these 7 basics align very closely with the learning modules in this course. So to review, what is computer science? Well, computer science is automated problem solving using digital information. And you might be interested to know that computer science has some interesting abilities when you decide to leave and graduate college. Do you know how many more jobs in computer science there are than projected graduates? About 1 million more jobs than we have students who are graduating with computer science degrees. So not only is this a critically important topic to learn about in terms of computer science, it also is highly lucrative. And in fact, the workforce is rather small. Do you know approximately how many students graduate with a computer science degree? Well, it's only about 2%. Even though 60% of all STEM jobs are computing jobs, only 2% of the STEM students are computer scientists. And those students that combine computer science with other fields of interest, such as journalism, art, public policy, you name it, there's going to be a computational version of that field out there. The students that are interested in melding and merging these disparate fields are going to be really well placed in the coming decades to really innovate and get lucrative jobs that have staying power.